Hi there everyone. Our session for today is a continuation of what we had last time, which is about the rational root theorem. But in this session, we'll be focusing on irrational and imaginary roots. And these are our learning targets. Now, let's begin first with defining what irrational is. So take note, when I say irrational numbers, those are simply numbers that express an infinite decimal answer. Like for example, I'm going to give you the square root of 3. If you will be using your calculator, the square root of 3 will give you a decimal answer. Same thing with the square root of 2, the square root of 5. So if in case you'll be extracting square roots, and then the answer in your calculator is a decimal number and it's unending, and there's no pattern on it, then it is irrational. Again, irrational are simply infinite decimals and no digits are repeating there. Now let's have our first example. So let's get the roots or the zeros of this polynomial. So I'm gonna be starting with, I have already used 1, -1, 2, and -2 a while ago, and I'll be using 4 this time. So using 4, synthetic again. So when we solve roots, we always start with synthetic division. That if you have a degree of 3 or more. So we have here 4, then the coefficients are 1, -4, -2, and 8. So doing synthetic, bring down 1, multiply, that's 4, that's 0, multiply, that's 0, you combine this, that's -2, multiply, that's -8, and we have a remainder of 0. Therefore, this one is already a root. This is already a root. Now, to solve the other roots, diba, with our previous lesson, we made factoring. But if you're gonna express this, transform this into an expression, diba, you will have x squared minus 2. And take note, x squared minus 2 is not factorable. Therefore, I will not be using factoring method here. Instead, we will have the quadratic formula. That is -b plus minus the square root of b squared minus 4ac all over 2a. So take note, go back to your synthetic. The 3 numbers here are simply the values of A, B, and C. Therefore, our A is 1, our B is 0, and our C is -2. These 3 values here will be substituted to your quadratic formula. So we will be having now x is equal to -b, that's -0, plus minus the square root of b squared, that's 0 squared, minus 4a, that's 1, c, that's -2, all over 2a, that's 2 times 1. So let's simplify this. This one is 0, this is 0, this one is also 0. So what is left is -4 times 1 times -2. So this is now positive, negative. That's totally right. That's 8 because 4 times 1 times 2 is 8. And negative times negative is positive. All over 2. Now take note, the square root of 8 can still be simplified. But there is a factor of 8 such that one factor is a perfect square. And that will give us 4 times 2. All over 2. So therefore, what is the square root of 2? I mean, the square root of 4. That would give us 2. You write that outside. Square root of 2, which is this one, all over 2. And we can cancel out this. So our x is simply positive negative square root of 2. So therefore, our roots are, starting with what number we use in our synthetic division, that's 4. And the results in our quadratic formula, starting with the positive number, that's positive square root of 2. followed by the -1, the negative square root of 2. And this will be our answer. These are our roots for this example. Let's have another example. This one. So we have 2x cubed plus 7x squared minus 5. So let's use -1 for this. Let's start with -1. So I have 2, 7. No, it's not -5. It should be 0 since the variable x is missing. And then you have the number 5. Let's do synthetic now. Bring down 2, multiply, that's -2. This is 5. When you combine, then multiply, that's -5. This is sorry. This is -5, by the way. -5 multiply, that's +5. This is 0. And take note, if you will express this as an expression, it is not factorable. Therefore, we will be using the quadratic formula again, which is -b plus minus b squared minus 4ac all over 2a. And this is a, this is b, and this is c. So substituting these three values in the quadratic formula, it will give us -b, that's -5, plus minus the square root of b squared, which is 5 squared, minus 4a, that's 2, c, that's -5, all over 2a, that's 2 times 2. So x is simply equal to, that's -5 plus minus, this is 25, -4 times 2 is -8, -8 times -5 is positive, 40 is right, all over 4. So x is equal to -5 plus minus the square root of 25 plus 40, that's 65, all over 4. Now, are there factors of 65 wherein one factor is a perfect square? Is it possible? It's not possible. So if it's not possible, then this is already the final answer for your quadratic formula. So writing all the roots now, starting off with the number we used a while ago with our synthetic, that's -1, and the result we had with our quadratic, ato ning breaking down positive and negative. So starting off with -5 plus the square root of 65 all over 4, and also -5 minus the square root of 65 all over 4, and those are your roots. Okay? Let's have imaginary now. So imaginary roots, a number that is expressed in terms of the square root of a negative number. So take note, the square root of -1 is simply I. It means imaginary. So if I'm going to take the square root of -9, it's not +3. It should be, I'm going to factor 9 as 9 times -1. So we have here the square root of 9 is 3. Square root of -1. So instead of writing the square root of -1, so the square root of -1 is equal to I. So this is simply 3i. Okay? Now let's have our first example. So we have your x cubed plus 3x squared plus 27x minus 31. Let's get the roots there. This is our polynomial function. Now, to get the roots, we have, let's try 1. So we have the coefficients 1, 3, 27, and -31. Bring down 1, multiply, that's 1, combining, that's 4, multiply, that's 4, you add this 31, multiply, that's 31, we have a remainder of 0. Therefore, this is already a root. Okay? To find the other roots, take note, if I'm going to express this as an expression, I cannot do factoring because walay factors ang 31 nga add na ko si 4. Okay? So, using the quadratic formula, which is x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. So we now have x is equal to, this is our a, this is our b, and this is our c. A, b, and c. Substituting these values over here, so we will have negative 4 plus minus the square root of 4 squared minus 4 times 1 times 31 all over 2 times 1. So solving this one, let's solve this now. We now have, simplify this, you will have x is equal to negative 4 plus minus the square root of square 4, that's 16, minus 4 times 1 times 31, you will get 124 for that. And 124, that's negative, combine these two, take note that's over 2, combining the 2, you will be getting negative 108 all over 2. Now, let's think of factors of 108. Factors of negative 108 such that one factor is a perfect square. Is there such factor? Yes, there is. We will have negative 4 plus minus the square root of 36, very good, times negative 3. So take note, 36 times negative 3 is 108, and 36 is a perfect square. Therefore, we will be having x is equal to, so this is negative 4, plus minus the square root of 36 is 6, the square root of 3, nya ang negative sign mahimo ng I, all over 2. Now, let's simplify this further because we can divide 4 and 6 by 2. So, negative 4 divided by 2, that's negative 4 divided by 2, that's negative 2. Plus, minus, 6 divided by 2, that's 3. The square root of 3, and you have an I there. And, take note, our roots are, starting off with the number we used a while ago when we did synthetic, that's 1, and breaking down the result in our quadratic, so we have negative 2 starting off with plus 3 square root of 3i, and we have negative 2 minus 3 square root of 3i, and these are your roots. Okay, let's have our last example. This one. So we have x cubed minus 27. Let's get the roots here. So for example, I am going to start off with positive 3. Okay? So we have 1, 0 for x squared, 0 for x, and the constant term 27. By the way, I already did 1 and negative 1. We cannot get 0 for the remainder. So I have tried. I will be trying 3 for this. So bring down 1. Then you have multiply, that's 3. Combining 3, multiply, that's 9. This is 9. Multiply, that's 27. And you will get a 0. And take note, this one will not be factorable if you will transform this into an expression. So I'm going to be using the quadratic formula where a, b, c, and c are these one. So x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. Now, x is equal to negative b, that's negative 3, plus minus the square root of b squared, that's 3 squared, minus 4ac4 times 1 times 9 all over 2 times 1. So let's multiply and simplify the exponents there. So you have negative 3 plus minus the square root of 3 squared is 9. 4 times 1 times 9, that's 36 all over 2. So we have negative 3 plus minus the square root of negative 27 all over 2. So simplifying 27, the square root of 27. Yes, there is a factor of 27 such that one factor is a perfect square. And that is 9 times negative 3. I totally agree with that. So we will have negative 3 plus minus the square root of 9 and negative 3 all over 2. So extracting, you copy negative 3, the square root of 9, that will give us 3. Write 3 outside. The square root of 3, because the negative sign will be written as I all over 2. Since I cannot divide 3 and 3 by 2, this is already final answer na to sa quadratic. Therefore, our roots are starting off with the number 3 over here, and then breaking down the result of what we had sa quadratic formula. That's negative 3 starting off with plus 3 square root of 3i all over 2, and the second one over here, that will be negative 3 minus 3, the square root of 3i over 2. And these are our roots. And that ends